Hello, in this video we'll be looking at the transformer. As the name suggests, a transformer transforms something, and generally speaking it transforms electrical supply. Often it's used to step up voltage produced in power stations up to the very high transmission power, potentials of up to 400,000 volts, and then also used to step down to a substation, a step down to eventually to our homes, which is 230 volts. So that's also useful to step up voltage and step down voltage. It also steps down current as well. Okay, now we've already got some stuff on the board. Let's have a look at what there is. So we got P, which stands for primary coil. So this is the primary coil. So what a transformer is you've got, imagine this in 3 dimensions, you've got a laminated iron core. Now, laminated means there are strips of iron with glue in between. Now, the glue acts as an insulator to help prevent lots of eddy currents, which make it inefficient. And eddy currents are produced with changing magnetic fields. So we don't want little mini eddy currents in there. We want it to be as efficient as possible. And the laminated iron core also helps contain the magnetic field. Now the magnetic field is produced by an AC. So we've got an AC supply here, changing backwards and forward at a certain frequency in this coil. And if you've got electricity going through a coil, of course, you will get a magnetic field. So first of all, you've got an AC in your primary coil. Okay. Now N is the number of turns. We'll talk about that. So these are the turns there and turns there, and N there stands for the number of turns. So here we have our AC is in our primary. Now with this constantly changing, obviously we get a magnetic field, and we'll get a constantly changing magnetic field is produced. Now this changing magnetic field, which is contained within the iron core, so it remains more efficient. That will cut, if you like, the secondary coil. So we've got a magnetic field cutting conductor, and when you get a magnetic field cutting conductor, as in Faraday's law, which is that you get a changing magnetic flux, and with this constantly changing magnetic flux, so you get a changing magnetic flux. Okay, as the changing magnetic field cuts secondary coil, you get a changing magnetic flux, and this will induce an EMF in the secondary coil, and it will be the same frequency as the frequency in the primary coil. So if we look at some equations here, so first of all, you've got P for primary coil, S is for secondary coil, N is the number of turns, and you find that your ratio of your the voltage across the secondary divided by the voltage, the EMF, if you like, across the primary, is equal to the ratio of the number of turns on the secondary coil divided by the number of turns on the primary coil. And using that equation, you'll find effectively if you've got more coils on the secondary than the primary, you'll get a step up. So 10 volts could go up to 100 volts, for instance. And if you've got more coils on the primary and less than the secondary, you'll find that your voltage will step down. Conversely, now your current will do the opposite. So if you've got more coils on the secondary, your current will go down. Now if you look at this, so that is the equation, that is, if you like, the transformer equation for step up and step down, is that one here. Okay, this one here it relates to a perfectly efficient transformer, and they are quite efficient. They're not 100% efficient, but there is a high efficiency, and you'll find the current in the primary coil times the voltage in the primary coil is equal to current in the secondary coil times the voltage in the secondary coil. And maybe sometimes you get a multiplying factor there to show you, or there, it depends on what you put down, to show you that it is not 100% efficient. Okay, and that is how a transformer works.